Okay, let's take a look at the Chapter 12 review, test review. I'm sorry the font is so small, but when I try to make it larger, it becomes very blurry. So hopefully you have your review sheet in front of you, and we'll just walk through the answers using the diagrams as best we can. So we'll start with number 1. Assume the lines that appear to be tangent are tangent. Find the value of A. Well, that's your clue to tell you if these are tangent. Remember, if a line is tangent to a circle, it's perpendicular to the radius at the point of tangency. So I have this quadrilateral now, right here. I have two right angles. I have an angle that is 30 degrees, so two right angles, an angle that is 130 degrees, and x, the sum of the interior angles of a quadrilateral, is 360. So therefore I have 90. 310 plus x equals 360. So x is equal to 50 degrees, which is that angle measure. Okay, number 2, again it says assume lines that appear to be tangent are tangent. Therefore, this angle right here is the line that is tangent. The value of x is the length of this entire line. That's the length of the hypotenuse. So we have 10 squared plus 24 squared equals x squared. So 100 plus 576 is equal to x squared. So 676 equals x squared. The square root of 676 is 26. So x is equal to 26. Number 3, I have to make a little correction. This value is actually 15. It says the polygon is circumscribed about the circle. The perimeter is 72 centimeters. Determine the length of AB. So we'll call AB x. Remember that when two lines are tangent to a circle and they intersect at a point outside the circle, then those segments are congruent. So x, AB, is congruent to BC. This length 9 is congruent to this length, which would be 9. Therefore, this length would be 9. This length would be 9. And this length will be 15. So what we have is 15 plus 15 plus 9 plus 9 plus 9 plus 9 plus x equals 72. So 66 plus 2x equals 72. 72 minus 66 is 6. 2x equals 6. So x is equal to 3. Number 4, this is just like number 2, except now the length of this longest leg, the hypotenuse, is a binomial. Remember, it says assume lines that appear to be tangent are tangent. So therefore, this is the hypotenuse. This length right here is x plus 8, the sum of those values. So now I have x squared plus 12 squared equals x plus 8 squared. Remember, you have to FOIL that binomial. Don't just tell me it's x squared plus 64. That would be incorrect. You have x squared plus 12 squared. Square these right away. Don't remember to get the goof. Don't try to subtract numbers before you've completed the square. Remember to FOIL these on the right so you get x squared plus 8x plus 8x plus 64. And on the right, combine like terms. So you have x squared plus 144 equals x squared plus 16x plus 64. Now you can subtract x squared from both sides, and they will cancel. Then you have 144 is equal to 16x plus 64. Subtract 64 from both sides, and you'll get that 16x is equal to 80. So x is equal to 5. So the length of the radius of the circle is 5 units. Number 5, we saw this early in the chapter. It says find a belt fits snugly around 2 circular pulleys as shown. So these are tangent. Find the distance between the 2 center pulleys. So I have a right angle here and a right angle here. Remember, the trick to this problem was to draw that line parallel. That line is parallel to the line connecting the 2 centers. So we're actually looking at this right triangle. We're going to call this length, that's the hypotenuse, that's x. The difference, or the length of this line, is the difference between the radius of the large circle and the radius of the small circle. So that is 9. So I have 9 squared plus 12 squared equals x squared. 81 plus 144 equals x squared. That gives me 225 equals x squared. So x is equal to 15. Remember, you take the square root of that. Next year in Algebra 2, you'll get 2 answers, positive and negative 15. But because we're talking about a distance, we only want the positive value. Number 6, find the values of the given variables. Well, when you look at this, you can hopefully see that this line passes through the center, therefore making it the diameter of a circle, making z equal to 180 degrees. It's half a circle. And also you have the end points of this inscribed angle are on the end points of the diameter, making this a right angle. So you can find this angle measure by taking 180 minus 90 minus 72, and you'll get that that angle is 18 degrees. Remember the relationship between the inscribed angle and its intercepted arc is the angle is half the arc measure, so therefore y is twice the inscribed angle, making it 36 degrees. You know that there are 360 degrees in the whole circle, 180 degrees in half a circle. So if you take 180 minus 36, you get that x is equal to 144 degrees. Okay, these are just like puzzles. As soon as you find something out, you should write it on the picture because it will help you find another piece on the picture. Number 7 says find the value of the given variables. So again, when you look at this, there are a couple things that you should remember. The inscribed angle, so this is the inscribed angle, is half the measure of this intercepted arc. What's that intercepted arc? 145 degrees, because it's the sum of those 2 arcs. So that means that C is 145 divided by 2, or C is equal to 72.5. Another thing you know is if you have a quadrilateral inscribed in a circle, then opposite angles are supplementary. So if A and C are supplementary, that means if I take 180 minus 72.5, I will find angle A, which is 107.5 degrees. Then I need to go and find either B or D. I'll take a look at B. There's my inscribed angle. Here's my intercepted arc for those two. So that is an arc measure of 200 degrees. So therefore, B is equal to half that, 100 degrees. And D, remember they're supplementary, so the sum of B and D is 180. If you subtract B, which is 100, you get that D is 80 degrees. Number 8, find the value of the given variables. Don't be fooled by this one. You have an inscribed angle, Y, which has an arc measure of 94. So therefore, Y is equal to 47 degrees. You have this angle as well, inscribed angle X. It shares the same arc as Y, so therefore X is also equal to 47 degrees. Now number 9, I have two secants intersecting inside a circle. So I take the large angle measure, 115, plus the small angle measure, which is X, and that's equal to 2 times the angle measure of 78. So I have 115 plus X equals 78 times 2, which is 156. Subtract 115 from both sides, and you'll get that X is equal to 41 degrees. Number 10, I have another set of secants intersecting inside the circle. So again, I take 2 times one angle, or excuse me, not 2 times, excuse me, I'm taking the angle measure 56 plus the angle measure 78, and that's equal to 2 times the angle measure, which is X. 56 plus 78 is 134, which equals 2x. Divide by 2, you'll get the angle measure is 67 degrees. Okay. The formula, remember, is 56 plus 78 over 2 equals x. But you can easily, instead of dividing the sum of the arc measures by 2, you can multiply the angle measure by 2. It's the same thing, and I think the algebra is just a little bit easier to look at. Okay, then we need y. Well, we know that x and y are supplementary angles, so 180 minus 67 gives me 113 degrees for y. Number 11, now I have two secants, but they are intersecting outside of the circle. So now I'm going to take the large arc minus the small arc, which is 40, and that's equal to 2 times the measure of that angle x. So I'm going to have 66 is equal to 2x, divide by 2, so that angle x is equal to 33 degrees. Okay, remember again, you can take 106 minus 40 over 2 equals x. This is actually just the second step of that same equation, and I think also a little easier. Okay, number 12, now I have a secant and a tangent. So when I look at this, my tangent line is x. Remember, the formula is the tangent squared, so x squared is equal to the length of the secant, which is 12 plus 6, times that part that is outside the circle. So I have x squared is equal to 18 times 6. So x squared is equal to 108. The square root of 108 can be written in simplest radical form as the square root of 36 times the square root of 3, which is 6 root 3. And the square root of 108 is approximately equal to 10.4. And the decimal approximation will be fine. Okay. Number 13, determine the center and radius of the circle given the following equation. Remember, standard form of the equation of a circle is x minus h squared plus y minus k squared equals r squared, where h and k are the center and r is the radius. So when I look at this, I have x minus negative 6 would be what gives me, so I have to have a negative 6 in order to get that to be plus, and then a 2. So the center is at minus 6, 2. The radius is the square root of 64, which is 8. Number 4 says write the standard form of the equation with a center at 5, 7 and a radius of 12. So you're just going to substitute the 5 in for h, the 7 in for k, and the 12 in for r. So you have x minus 5 squared plus y minus 7 squared equals 144. You're simply substituting those values in and solving that. Number 15 is a little more challenging. It asks you to write the standard form of the equation of the circle with end points of the diameter at minus 2, and 8, 6. So if you think about this, here's my circle, there are the end points of my diameter. The center of that, the midpoint of that line, is the center of the circle. So all we have to do is use the midpoint formula. So I have minus 2 plus 8 over 2, minus 2 plus 6 over 2. So that gives me 6 over 2, which is 3, and 4 over 2, which is 2. So the center of my diameter, or the midpoint of my diameter, is the center of my circle, which is at 3, 2. Then I need to find the radius. The radius, remember, is from the center to one of the points on the circle. So we'll pick 8, 6. So we have to use the distance formula. The square root of 3 minus 8 squared plus 2 minus 6 squared. So 3 minus 8 is negative 5. Negative 5 squared is 25. 2 minus 6 is negative 4. Negative 4 squared is 16. So I'm looking at a radius with a square root of 41. I'm asked to write the equation in standard form. So that's x minus 3 squared plus y minus 2 squared equals r squared, which would just be 41. So that's the standard form of the equation of that circle with endpoints of the diameter at minus 2, and 8, 6. Process is to find the midpoint and then use the distance formula to find the radius. Last question, number 16. Describe and draw the locus of points 1 centimeter from segment AB and 2 centimeters from A, where AB is 1.5. So if this is AB, and it is 1.5, and then we need all of the points 1 centimeter from AB. It's going to be this oval. And then we want it to be 2 meters or 2 centimeters from A and B, or from A. So that's going to be this circle. So the locus of all points where they intersect, where that 1 centimeter from AB and 2 centimeters from A intersect, are right here and right here. So those are the 2 points that make up the locus of points that satisfy both of those conditions. Again, the test tomorrow will be very similar to today's review. I hope the video is helpful, and I'll see you tomorrow. Have a good evening.